Viewers, welcome back to our YouTube channel. In this video, we are going to discuss about the three-sum problem, where we are initially given with an integer array called nums, and we have to figure out three numbers such that their sum should be equivalent to 0. But while picking these three numbers, we ensure that each element should be picked from a different index, which signifies that every element should not be used more than once in that particular triplet. Got it? Let's quickly discuss with an example. Initially, we are given with an array called nums, and we have to figure out or pick three numbers such that their sum to be 0. If I am picking this, then this, then this, it makes sense because -1, 0, and 1, their sum comes to be a 0. And here the order doesn't matter whether you write 0, -1, 1 or 1, 0, -1, anything. The order doesn't matter. You have to just return any of the order that you wish to do. And another possible triplet is -1, -1 and 2, which gives me this, and the sum here it is 0. You can return it in any order. Therefore the two possible triplets are this and this, and you can see that here both are same, and you can see that the distant triplets are -1, 0, 1 and -1, -1, 2, and again they are saying that the same thing, the orders doesn't matter. And how can we do this? But before that, we're going to discuss the example 2. What if there is no possible triplet? Here when we do the sum, we get the sum as 2, but we require a sum of 0, right? Therefore there is no possible triplet. We have to return the empty list. Got it? And you can see that 0, 0, 0, if we sum them, we get again a 0, which is a possible triplet, and we are gonna return it, right? And let's discuss the most brute force approach for this solution. Now our motto is to pick the three numbers such that their sum should be 0. What if I use three for loops, nested for loops, and pick the elements one after one and sum them up, and if their sum is equal to 0, it is a valid, and then I'm gonna push them into a set because they doesn't allow duplicates. Therefore set handles it very well. And again at the end I'm gonna convert the set into a list because we have to return the output as a list of list. Got it? Makes sense? Then I'm gonna simulate. I put a pointer here, another j pointer here, another pointer k at here. Got it? Now the k moves first, but before we're gonna see that is it forming a valid one. -1, 0, 1, the sum is 0. It is forming a valid triplet. Therefore we're gonna push into our set. Now our set becomes something like -1, 0, 1. And if you have a deeper understanding of how sets stores, the set stores the things that are immutable, but here list is a mutable type. Therefore we're going to convert this list into a tuple format, then going to store it in the set. Make sense? Now it becomes something like this. Got it? Actually have to pick the first pointer I, which starts from 0 and goes towards n minus 2, and n will be the nums dot size. And why n minus 2 I will discuss, because 0, 1, 2, 3. Here the size is 4. 4 minus 2 gives me 2, right? 0, 1, 2, 3. But you can ask me why? Because why 4 minus 2? Because if I put it here, the last pointer, it goes until here itself. Makes sense, right? Because it always goes one element before it. Therefore the I only goes until this. Now j should be here and k should be here. Makes sense, right? And k should be here. Therefore we are done with the ith pointer where it goes. Now jth pointer. For j, it always starts with the next index of I and goes till n minus 1. If n minus 1 means it goes until n minus 2. Sorry, up to n minus 2. And k pointer for k starts from j plus 1 and goes till n. Again, n means it goes until the last element, right? Now, if nums of I plus nums of j plus nums of k equal to 0, if this equal to 0, then I found a valid one. Let's declare this set. Let the array set be the resultant, and it's a set. Now resultant dot add couple of this same thing, nums of I, nums of j, and nums of k. Got it? And we are done with this, and at the end we are simply going to return list of press. Got it? Let's quickly discuss the time and space complexity for this approach. This loop takes time complexity of order of n. It again takes a time complexity order of n, and it also does the same, and it's almost constant, these things. Now the time complexity becomes n cross n cross n, which is equivalent to order of n cube. The better solution for this approach is to sort these given nums and do a two-pointer approach to get the valid answer. When we sort this array, we get this array. Got it? And whenever we see a word like sorting or sorted, we initially think of binary search and two-pointer approach. Here we use the two-pointer approach to solve this problem. Initially we put a pointer I here, and the j is of course next to it, but now the k doesn't point towards the next index of j, it's going to point towards the last index. Now see that what is the possible triplet? minus 1 plus 2, which gives me minus 3. No, it doesn't get it. But if we see that the trajectory for a sorted array which is ascending order, which is sorted in ascending order, it goes something like this. If I get minus 3, I may get minus 2 here, minus 1 here, maybe 0 here. Got it? Because to increase the value, we should move it forward. To decrease the value, we should move it backward. You can see that we have to decrease, move it backward. To increase, move it forward. Make sense? Right? Then here we do the same thing. I get minus 3 value, but I want the value to be 0, right? Again I move it forward. Therefore the j moves forward, but the I and k will still remain there itself. Now the next possible is minus 4 minus 1 plus 2. Again same thing, minus 3. I need 0, right? I move it forward. Again now the triplet becomes minus 4 plus 0 plus 2, which gives me minus 2. See, makes sense here. I am moving forward, I get a value like minus 2, right? That is possible, like, but still it is not equal to 0. I'm gonna do the same thing, move it forward. Now minus 4 plus 1 plus 2, which gives me minus 1. Makes sense, but again not equal to 0. Move it forward. Now my j points at here. Minus 1 plus 2 plus 2 equal to 0. Yeah, we found a triplet, but it doesn't make sense because they explicitly said that every element should be picked from a different index. Means every element should be at most used once in that respective triplet. Here we are using the same element 2, 2 in the triplet, which is invalid. Therefore it doesn't gonna use this. But how to avoid this thing, like whenever we use the same thing, like when to avoid the condition when two pointers point towards the same element. it can be avoided using when j is lesser than k, because when it is equals to k, we are using the same element, right? Therefore I gonna use the condition j lesser than k. It avoids that condition, right? And let's quickly discuss the same thing. Now when we hit the condition when j is greater than k, we are done with that respected index I. We are gonna move that I forward. Now I stands at here. Again same thing, j here and k here. Now see, -1, -1, 2, 0. It's a valid triplet, therefore gonna store it in some data structure. Got it? Now what if I found a 0? What should I do? If I get a negative number, I'm gonna move it forward. If I get a number which is greater than like 2 or 3, I'm gonna move it backward. But what if I get the same equivalent? I do both things. I'm gonna move the j pointer forward and k pointer backward. Right? Now the another triplet becomes -1 plus 0 plus 1, which is 0. Another possible triplet, right? Again I'm gonna store it in the data structure. Again do the same thing. If I found the 0, I'm gonna increment the j and decrement the k. Violate the condition which is j is lesser than k. Therefore we are done with that respected I. And at the end we are left with these two triplets which are the most valid triplets. Therefore we are done with this. And let's quickly code this approach. Initially we have to sort the nums. You can use the nums.sort or sorted, but it's a good habit to not to disturb the given array. We're going to take another array and copy those elements and sort there, but here I sort it, and we're going to start iterating from I, which takes from 0 to n minus 2. And what is the j stands to initially? I place 1. Let n be the number which gives me nums.length or nums.size. I'm using a pseudocode type of approach because to make you understand what is n, but I'm not very trying to write a Pythonic code or any Java or CPP code. Therefore my k points towards the n minus 1. Now if I found, but yeah, we have to go through the condition like while j is lesser than k, then please do things. If the nums of I plus nums of j and nums of k, if it is lesser than 0, then we have to see that if it's lesser, we have to move the j pointer towards the front. Got it? If the same thing, if nums of I plus nums of j, or the better thing is to store this entire thing. Got it? Let me take a variable called sums and use it here. If sums is lesser than 0, then please increment the j pointer, and the same thing, if sums is greater than 0, decrement the k pointer. Else, if I found it is equal to 0, this is the case, and we have to push result that add tuple of nums of I, nums of j, and nums of k, and we're gonna increment the j and again decrement the j. Makes sense, right? And at the end of this for loop, we're gonna return the resultant, but we have to convert it into list. Initially not declared, resultant will be a set data structure and return list of rest. Got it? Now let's discuss the time and space complexity for this approach. If you see here, this definitely runs for order of n. Got it? Now this while condition, for what amount of time it runs. If you see that we are incrementing and decrementing, like if I have this list, we are incrementing and decrementing, means I am visiting every element present in that respected array. Therefore it takes me a time complexity of order of n, but I'm not gonna traversing every element more than twice, because I'm only traversing it for once, right? Therefore, it stays for order of n. Now the entire time complexity becomes order of n cross n, which is order of n square. And again, the time space complexity is still constant, but it depends upon the sorting algorithm that you are using, right? But we are not using any external data structure, but we are using resultant but to return it right at the end. And this is the better solution, but there exist so many other solutions which are done using without sorting also. You can visit the link that I am drop in the description, where it have a separate website. Threesome has a separate Wikipedia website where you can see various solutions to it. And if you understood everything, then please do like, share and subscribe. And if you have any queries, please list them in the comment section. Thank you.